Okay, so we're going to look at radicals and how to reduce them and combine, hopefully, a series of terms into one term. Now, there's a couple of main things that you need to keep an eye out for when you're doing this. First, in order to combine terms together, this stuff underneath the radicals here needs to match. Just like terms when we're dealing with x's and x squareds, like for example, if we have 3x plus 3x squared, we can't add those together because they're not like terms. So radicals are much like x's in that regard, in that they need to match exactly in order for us to combine them if they're added or subtracted from one another. So if we look at these, this first one here, the cubed root of 3, we actually can't reduce that down any further than it already is. What we're going to be looking for these other two terms, the cubed root of 24 and the cubed root of 81, is there a perfect cube that goes evenly into 24 that we can break this 24 into the pieces of? So this first one we're going to leave alone for now. 24, if you think about what the perfect cubes are, and I would actually recommend doing a search on the internet to get a list of perfect squares, perfect cubes, perfect fourths, because you'll need those to do this homework properly. So if we think about a perfect cube, which again, that's based on the little number that's out in front. If this is just a square root, like that, then you're looking for perfect squares that divide evenly into the numbers underneath the radical. If there's a little 4 out here, then you're looking for a number that you would multiply together 4 times that goes evenly into the number that's underneath the radical here. Okay, so if we go back to our original problem, we've got 24. So we can break that into 8 times 3, because 8 is a perfect cube. 8 is 2 times 2 times 2. So if we look at, we're going to leave this term alone. And this 4 out in front is just multiplied by our term here. I'm going to break this into the cubed root of 8 times 3. And then with 81, as it turns out, 27 goes evenly into 81. 27 is 3 cubed, 3 times 3 times 3. So I break this. Now again, hopefully this is a refresher for you. You should have seen this in 138. If this is all looking very new, I would recommend rereading the majority of the review chapters up until this point. So R1 through R6. Okay, so this term again we're leaving alone for now. This one, since we've got multiplication going on under the radical, one of our properties of radicals says that we can split that up. So now our problem becomes to so we've still got this 4 out in front, and that's going to be times the cubed root of 8 times the cubed root of 3. And then over here, I'm going to break this one also into the pieces, cubed root 27 times cubed root of 3. Now the reason I do that is because now these cubed roots of perfect cubes will simplify to nice whole numbers. So now we have the problem to cubed root 3 plus 4 times, now the cubed root of 8, as I mentioned, 4 is 2, so this is times 2, and then we've still got our times, sorry, this pen is all new to me, so this is an adventure for me and for you. Alright, so, and then we've got this cubed root of 27, which reduces down to 3, times, again, our cubed root of 3. Okay, so now we can simplify things down a little further. Again, this one is relatively as simplified as it will go, so that's going to stay the same. But now we've got this 4 times 2 out in front, so that's going to become 8 cubed root 3 and 3 cubed root 3. Okay, so now that we've done this reducing and broken down these larger numbers into the combination of a perfect cube times some other number, as you can see, now all of our terms underneath the radicals match. That's what we needed in order to combine these together. If these all match, then you can almost think of them like x's. So if you had the problem 2x plus 8x minus 3x, you'd know that that would be 2 plus 8, 10x minus 3x, or 7x, right? Well, it works much the same way with radicals. 2 times the cubed root of 3 plus 8 times the cubed root of 3 minus 3 times the cubed root of 3 is actually going to be 7 times the cubed root of 3.